Good afternoon, ladies and gentlemen. We're going to continue our series of videos on the performance of the Musclechuck. As you've already seen, we've done a video on finding the sweet spot and minimizing the runout, which turned out to be the runout of the router motor itself. Now we're going to show you two particular operations that verifies the holding power of the chuck, both radially and linearly. Well, what I mean by that is we're going to take a typical Musclechuck and a heat-treated Rockwell 65 hardened shaft, and we're going to install it in the Musclechuck, and we're going to show you how much breakaway torque it takes, radial breakaway torque, and how well the Musclechuck holds on to a tool. So without further ado, the first thing we're going to do is we're going to put this in the vise here, and we're going to torque the cap screw to 125 inch-pounds. Now this, as you see the dial, these are certified and calibrated torque wrenches. This is in inch-pounds, and you can see I have the blue telltale marker on 125 inch-pounds, which is where we're going to tighten the cap screw. There you go. We're at 125 inch-pounds on the cap screw. Now we're going to put the chuck in the vise in such a way against the screw to keep the chuck body from rotating. You put very little torque or compressive force with the vise on the chuck itself. Now what we're going to do is take our other torque wrench, which is in foot-pounds. As you can see, I have it set at about 33 foot-pounds or so. And we're going to rotate the shaft in the chuck relative to the body, and we'll see where that winds up. So as I begin to pull on it, you can see that the chuck body is not able to rotate, and we're going further and further and further and further, and that's about, it started to slip right there, and the telltale needle says about 43.5 foot-pounds. So with 125 inch-pounds of torque on the cap screw, you get about 43.5 foot-pounds of radial breakaway torque on your tool. Chances are, if you tried to make a cut with that much torque on your cutter, you'd probably stall the router. This will conclude the radial holding power of the Musclechuck, and now we're going to go over to the press, and we're going to set up, and we're going to put force on this to force it through the Musclechuck and see how well the Musclechuck holds on to the tool linearly. So now we're going to show you how much force it takes to push the same heat-treated shaft out of the Musclechuck linearly. We have it mounted in a press, as you can see. This is the ram of the press, and the gauge here is not that accurate, but it's calibrated in tons. It's a 12-ton press, and you can see each mark is 1 ton. Okay, so now without further ado, we are going to put some linear force on the shank of the tool here, and we're going to see what it does. You'll notice that we have the shaft marked to show you where it's at in the chuck. So here we go. You can see it starting to move. Okay. The gauge is reading approximately 1 ton. So you can see it takes about 1 ton of linear force to force the heat-treated shaft out of the Musclechuck. And incidentally, if you tried to do the same thing with a cam chuck, you would put a line like plowing a field into the shank of the tool with the cam, because the cam has to be hard or harder than the shank of the tool without deforming. The Musclechuck will not damage your shank of your tool, so you need a ton of force to push this tool out. And off the top of my head, I cannot think of a cut that you have to make in wood that would take that kind of a linear pull. I cut metal with these things, and I have never had them come out under any circumstances. And again, 125 inch-pounds of torque on the cap screw, which is a little over a quarter of a turn, with a 4mm wrench, hex wrench, and you'll get about 125 inch-pounds of torque. And that's what you need for approximately 1 ton of linear force to force the tool out of the chuck. I thank you for watching the video, and I thank you also for your interest in our product. Thank you.